Hey guys, BuildZoid here, and today I want to talk a little bit about GPU repairability because of this post that I saw on r/GPU repair about a 3080 Ti Founders Edition, which evidently suffered what looks like a pretty typical power stage failure to me, 2 weeks after the warranty expired. So the point of this video is basically I think it's ridiculous that very expensive GPUs these days don't come with fuses. Because, yeah, if this card had a fuse, uh, instead of the power stage dying and burning a hole in the PCB, it would burn a hole in the fuse, and then the card would be repairable. Unfortunately for the owner of this card, I wouldn't consider this repairable, for a couple reasons. Actually, well, for basically just one reason. This is a 3080 Ti Founders Edition, and the dead power stage is in an incredibly dense part of the board, right? Um, like looking at one of the other photos over here, like we can see that the power stage that failed is this one over here because we can see all of these like reflowed solder joints. We also have this ball of solder that got like ejected from under the power stage when it died, which is pretty typical because what happens when a power stage dies, usually the high side MOSFET shorts out, so that connects 12 volts straight to the output. Typically, sometimes it'll connect 12 volts straight to ground, but either way, 12 volts gets completely shorted out, and then the short circuit pulls, like, just keeps pulling more and more current um, until the overcurrent protection of the power supply kicks in or something along the chain burns out. I have seen some GPUs where you have like shunt resistors that ended up acting as fuses, as in the power stage pulled so much power that it melted a shunt resistor. I've seen melted inductors as well. This card actually has some signs of that. Like if you look at this, you can see this inductor over here cracked because this is the input filtering inductor for the PCIe slot. So basically 12 volts comes in through the PCIe slot, goes through this shunt resistor, goes through this inductor, and then it goes over to this power stage that died. And when that power stage died, it pulled so much current that this inductor got so hot that it cracked. But basically, so as far as I'm concerned, this looks like a pretty typical power stage failure. And the main point is that all of this damage could be drastically reduced if the card just had a fuse. And these things cost nothing. These things are like 4 cents a piece. But of course, this is an Nvidia Founders Edition. It costs $1,200. Nvidia does not have the money necessary to add a 4-cent fuse on a card with a $1,200 MSRP. Um, so, yeah, but I just think that's just completely insane. That, like, you know, like GPUs are now, like, historically GPUs didn't have fuses, and in the past, I'd say it kind of made sense, right? Like, if you had a GTX 580 and it died 4 years after you purchased it, you're not going to go get it repaired. Like that just doesn't make sense, right? Like the card is basically obsolete in terms of performance after 4 years. But this is a 3080 Ti Founders Edition. If you want to replace one of these today with a card of equivalent performance that's new, you're looking at an RTX 4070 as a minimum, right? And that's like a $600 GPU or like $500 to $600 GPU. So like the minimum replacement for this thing is very expensive. Whereas repairing this, like the power stage is like $2 to $5. Like $5 is really on the high side for that. The inductor is that's not going to really cost anything to replace. Um, so like repairing this, if it weren't for the fact that the power stage burnt a hole in one of the densest parts of the board, right? Like we've got like we're gonna have like 5 volts running through here, 12 volts. There's gonna be ground planes, display lines, power sequencing, probably some PWM signals running through the area because like the voltage controllers are on this side of the board, and we have a bunch of power stages over here. So you're gonna be running like there's gonna be PWM lines running over there. Um, and so, like, replacing that power stage, like, that wouldn't really cost that much. But the hole in the board, like, the way you usually would fix this, if it weren't in such a bad location, is that you'd drill this out. But if you drill this out here, like, you're just screwed. Like, it's just going to disable the rest of the card. I mean, it's already disabled the entire card, but, like, you drill this out, and there's just going to be so many signals that you need to reconnect. And as far as I know, 3080 Ti Founders Edition cards are like 12 or 14 layer PCBs. Nobody's going to want to, like, that's not, like, you're, like, this is spare parts. Like, the most sensible way of trying to fix this at this point, considering the damage to the PCB, would be to have a card that's missing the GPU core and memory chips, and take the core and memory chips off of this card and put it onto a good PCB. And I'm relatively certain that actually the core in this case survived, because the power stage that died is this one over here, and that's a V-core power stage. And usually, even if the card doesn't have a fuse, V-core power stage failures don't tend to kill the silicon. Memory power stage failures have a very high tendency to kill the memory chips and like kill the memory controller and turn the whole card into spare parts. Sometimes, even if you have a fuse, a memory power failure will just destroy the entire card, not just the PCB, but also like all of the expensive parts like the GPU core. But V-core failures, in my experience, they don't tend to kill silicon very often. I have a 2080 Ti with a dead power stage, no fuse, works fine. As in, I fixed it. It didn't work until I got my hands on it, but so yeah, I have a 2080 Ti that survived a failing V-core power stage, an RX 480 that survived a failing V-core power stage, an RX 580 that survived a failed V-core power stage, a whole bunch of 980 Ti's with failed V-core power stages. Like, this is, like, if it weren't for the fact that it burnt a hole in the board, this is entirely survivable and repairable, but it's a Founders Edition, there's no fuse, it burnt a hole in the board. So the owner of this card is kind of screwed. And I do think that's just completely insane, because that burn could have been almost entirely prevented by a 4-cent fuse. Right? Because, again, like when that power stage fails, instead of burning a hole in the PCB until your power supply overcurrent protection trips, which this is a 3080 Ti Founders Edition, chances are that the power supply this is hooked up to is like 1,000 watts. That power supply isn't going to cut power until this short circuit pulls more than 90 amps. Or more than 100 amps, actually. Like, it depends. Like, an 850 would probably cut out somewhere between 90 and 100 amps. A 1,000-watt power supply, I would expect it to cut out above 100 amps. You have like a 1200-watt PSU, it's not going to cut out until like 110, 120 amps output. So that's how you end up with this much damage. Whereas if you had a fuse, that fuse is 20 amps. Like, if you overload it by, you know, by a significant amount, that fuse is going to pop incredibly quickly. Now, it's not going to completely prevent all damage. Like I mentioned earlier, sometimes, you know, if you have a memory VRM fail, even if there's a fuse in front of it, and it blows the fuse doesn't necessarily blow quickly enough to prevent damage to the memory chips and the GPU's memory controller. Also, in my experience, even on cards where you do have fuses, a lot of the time the power stage will still manage to weld itself to the board. I have direct experience with that on these Gigabyte 3090s. I actually got the opportunity to repair 2 of these. But Gigabyte, unlike Nvidia, can, you know, afford 4 cents for some fuses. So there's a fuse on each of the power connectors over here, and one for the PCIe slot. And so when I got these 3090s, like, repairing it was basically just a matter of identifying the dead power stage, which was somewhat simpler thanks to the fuses. And then it was just a matter of replacing the dead power stages. Now, if I remember correctly, the V-core power stages on both cards did manage to weld themselves to, I think, the switch node. Which is just usually what happens when a power stage, like, for some reason, like, you'd think it would weld itself to 12 volts, but usually it's the switch node that it ends up welding itself to. Probably because the switch node has relatively low thermal mass compared to some of the other power planes in the area. So it's really easy to get it up to a temperature where the copper actually, like, starts welding. But anyway, so, you know, like, the fact that the power stage welded itself into place was not convenient, but it was still way better than having to deal with this. And so I was able to successfully repair both 3090s. Like, ultimately, I ended up ripping the power stages off with whatever it welded itself to, and then rebuilding the broken pad with some, like, copper tape, or, like, sheet copper. Like, yeah, I have some, like, very thin copper foil that I use for repairing broken pads like that. So, you know, and so I was able to fix this because the card has fuses. So when the power stage goes, it doesn't just burn a hole in the PCB, it burns it in the fuse. Sure, it still managed to weld itself to the card, but that's minor relative to, you know, having a burn short circuit through 12 layers of board. if not more than that. Again, I'm not 100% certain if the 3080 Ti Founders Edition is 12 or 14 layers. That doesn't really matter. Like, either way, this is not practical to fix. And the thing is, so historically, like, fuses didn't make that much sense because your card would become obsolete very quickly, and like spending money on repairing it didn't make sense. But these days, GPUs are extremely expensive. Performance progress has slowed down to a crawl. So a high-end GPU from like 4 years ago isn't completely obsolete today. And so it would actually make sense to be able to repair the damn things. But unfortunately, Nvidia has sort of made it even worse, right? So of course, like, the Nvidia Founders Edition doesn't have any fuses. Nvidia doesn't give a damn about repairability. But, you know, their board partners like Gigabyte, and not all board partners add fuses, like Asus, which I find really funny. Back in the GTX 500 series days, Asus did use fuses, and then with the 600 series, they decided to stop, and they've never put fuses on a card since, as far as I know. But anyway, so like Gigabyte on their 30 series, they were putting fuses on these cards. MSI with their 30 series, you have a fuse for each of the power connectors, right? One for the PCIe slot down here, one for each of the 8 pins. That's all good. Then we get to the 3090 Ti, and we still have a fuse for the PCIe slot. Incidentally, I'm not a fan of the fact that MSI is using a 20 amp fuse on the PCIe slot. Like, it's still way better than what Nvidia did, which is nothing. But I think for the PCIe slot, you should probably be using a 10 amp fuse, not a 20. But anyway, a 20 amp fuse is still a lot better than nothing. So we have a 20 amp fuse on the PCIe slot, and then we have 3 fuses for the 12 volt high power connector, and these are not in parallel. It kind of looks like it is, but on a 3090 Ti, you still have 3 separate 12 volt regions. So basically, the way you can think of this fuse setup is each fuse is going to be connected to, I'm guessing, 8 phases of vCore. Or 8 power stages of vCore, not necessarily 8 phases, because the way these cards are set up, it's, I believe, 3 power stages per phase. So you might actually have, like, how does that work out? Like 3 phases? 3.5 phases per fuse? Something like that. It'll be really weird. Yeah, I'm not sure. So I'm not exactly sure what the, like, power, like, alignment, like, assignment is. But the idea is that, like, you do have a 20 amp fuse for a, like, 1/3 of the vCore VRM, right? And that's possible because the 12 volt high power connector on these cards is treated the same way as the 3 8 pins on the other 30 series cards. And so this is a perfectly good way of doing this, because if one of these power stages blows, it's just going to blow the fuse that it's connected to, and that's all good. And then we get to the 4090, and with the 4090, things get significantly worse because the 12 volt high power connector is no longer treated as 3 separate 12 volt regions. It's one big 12 volt blob. MSI still did their very best and managed to squeeze. So we still have this fuse over here, but it's not for the 12 volt high power connector anymore. It's for the memory power delivery. And I still think that's, like, very much a good thing, because like I mentioned earlier, memory power stages dying have a tendency to destroy the memory system. Like, very, very regularly, they will destroy memory chips and the memory controller. So having a way to very quickly cut power from the from the memory VRM in case it fails is a good thing, as far as I'm concerned. Honestly, I think it would be really cool if memory power delivery on some cards actually, like, experimented with maybe even going as far as having, like, 1 fuse per power stage, because that way the fuse can be even smaller. And that'll make it blow faster if it gets, like, if the power stage fails. But I'm not sure if there's, like, some practical, like, obviously there's a cost issue with doing that, but I'm also kind of wondering, with, like, the voltage regulator being a switching component, how is that going to interact with the fuse? I'm not entirely certain. But I think it would be cool if it was possible to, instead of having one big 20 amp fuse for 4 memory power stages, if it was like 1 5 amp fuse per power stage, or like a 6 amp fuse per power stage. Because I think that, like, that would be better in the scenario where one of the power stages dies. But anyway, we do still have a fuse on the PCIe slot, and this time it's more appropriately sized. It's a 12 amp instead of a 20, so that I do consider a good thing. But yeah, so we've gone from having like fuses for literally every single power input on the 3090 Ti. Oh, that's not a 3090 Ti. This is a 3090 Ti. Um, so we've gone from having a fuse for every single power input to only having fuses for the PCIe slot and the memory power delivery. And if the vCore VRM on this fails, it could do the exact same thing as this 3080 Ti Founders Edition did. Now, I think it's kind of unlikely with these power stages that this MSI card is using, because these are monolithic power systems, power stages, and these do integrate some like safety features for short circuit protection and that kind of thing. However, so does the 3080 Ti Founders Edition. At least the one that Tech Power Up got, right? This uses also the MP86957, which is exactly the same power stages used on this 4090, and even this, even this 3090 Ti. But the funny thing about this card that's on Reddit here, this 3080 Ti Founders Edition that has the burn in it, this uses Fairchild Semiconductor FDM F3170s. These, as far as I know, don't have a lot of those extra safety features that the monolithic power systems parts do. And this isn't really that surprising because one of the whole points of the Smart Power Stage standard is that they're supposed to be footprint compatible with each other. The idea being, the point of that is that sometimes you just get power stage shortages. Like, that is actually a thing. And especially with the 30 series, it was super common. So you could find cards from like one board partner and 3090, and it would be the same PCB, but you'd get like 3 different flavors of power stages, as in like 3 different brands of power stages, and they'd all be used on the same PCB because they all use the same like power stage standard. They all have the same footprint, but they don't necessarily all have the same features or the same build quality or even the same like current ratings. They're roughly similar, but you wouldn't get 40 amp power stages on a PCB that's normally used with 50 amp power stages, but you would see like sometimes you'd get 50 amp, sometimes 55, sometimes 60. Sometimes it would be Vishay semiconductor, sometimes Alpha and Omega, sometimes I'm trying to think. I can't remember another one off the top of my head. But Vishay and Alpha Omega were like the common ones. And so I'm not really surprised that a 3080 Ti Founders Edition has Fairchild Semiconductor FDM F3170s on it, but it's really unfortunate for the owner of this card because chances are if it used the monolithic power systems parts, it wouldn't look like this right now. Though, regardless of which power stages it uses, if it had a fuse, it wouldn't look like this right now either. But, you know, Nvidia Founders Edition can't afford fuses. But anyway, so with the 4090, things have gotten worse. Right, like, and we do still have the monolithic power systems power stages, but we're not even guaranteed that you're going to get these, right? Like, I thought the 3080 Ti Founders Edition would always use MP86957s. Evidently not. You can get them with 3170s as well. And either way, like, I've seen power stages fail from, like, the 2080 Ti Strix that I have. That was a Texas Instruments part. The RX 580, I think, was a Alpha... Yeah, that, I think, was an Alpha and Omega semiconductor part. The RX 480 was an IR 3553. The 980 Ti, some of them are Fairchild semiconductor parts. Some of them are 3550s from International Rectifier, right? So basically every flavor of power stage. I mean, I haven't seen a burnt out short circuit level monolithic power systems part, but that's probably because they're relatively new on the market. Like, I first saw a monolithic power systems power stage used, I think, on a 30 series card. I don't think they were used before that. So they're like a relatively new-ish brand of power stages. They might also just be a rebrand of some other manufacturer. I don't know for sure. That's kind of funny, is like Fairchild Semiconductor is actually on semiconductor. Oh, that's the other one. Yeah, you can also get 3090s with like on semiconductor parts. So yeah, so like Fairchild and on semiconductor are technically kind of the same thing these days. But the point is, like, I've seen basically every brand of power stage short out and die. Like, that's just a thing that happens. And so, especially on high-end GPUs that cost, you know, over $1,000, it would be kind of nice if they had some 4-cent fuses, So, like, it's not super common that power stages die, but it's common in, like, it's one of the more common ways a high-end GPU is gonna fail, right? Like, your options are like power delivery failure and then BGA damage. That's basically it. That's like the two things that kill GPUs. Occasionally, you'll also get like cracked capacitors from like board flexing and that kind of thing, or cracked PCBs again because of the board flexing, which usually includes also BGA damage. Um, but even before like PCB cracking was a thing, like power stages dying was just like that's a thing. Like power stages die. Even good power stages die. On massively overbuilt cards, they still die. That's just a fact. An unfortunate one. Like I have a 980 Ti Hall of Fame where I replace which I repaired by replacing a dead power stage, right? So like put fuses on $1,000 GPUs. It just doesn't seem that unreasonable to me. But anyway, so 4090, we went from, 3090 Ti 4 fuses down to 2. And then you get to the 5090, and at this point, MSI has just completely given up. There's one fuse for the PCIe slot and nothing else. Because on this card, you don't even have the convenience of the memory power delivery having its own 12-volt region. Right, like this input filtering inductor, that's like dedicated input filtering for the memory power delivery. But if you look at the 5090, you have these two input filtering inductors, and that's it, I think. Like this, I think, is a 5-volt, right? Yeah, that's a 5-volt regulator, probably. We have an input filtering inductor on the PCIe slot, but that thing is absolutely tiny because, actually, I'm not even sure what it is. It's probably this. This looks like a 5-volt regulator. Yeah, this is probably a 5-volt regulator. That's probably the input filtering inductor over there. And this is probably just filtering the power for things like these two regulators down here, as well as probably the 5-volt regulators. So, basically, on this card, yeah, there's no fuses. Like, you have a fuse on the PCIe slot, and that's it. If one of the, like, again, luckily this does use monolithic power systems parts, so it probably won't burn a hole in the PCB if it dies. Yeah, well, they probably won't burn a hole in the PCB if one of them dies. But, it's a $2,000 GPU. Actually, I think the MSRP for the Suprim X from MSI is above that, isn't it? Yeah, it's $2,400, right? It's a $2,400 GPU. It's probably gonna last, like, in terms of being relevant in terms of performance, like, it could be relevant for the next 2 or 3, 4 years. I don't think the warranty is that long. It would be kind of nice if it had some 4-cent fuses. But unfortunately, because Nvidia controls the design of their boards, like the designs of their board partners extremely tightly, I can't imagine that MSI would get permission to actually split up the 12-volt distribution to add some fuses on here. Yeah, this is what you're stuck with. Anyway, so yeah, so like with the 5090, like even MSI has just completely given up. Now Zotac with the 5080, they're kind of trying to do something. They put 320 amp fuses in parallel next to each other. I am not convinced that this is actually effective because the whole point, like, the thing with fuses is that they don't blow instantly when you reach their current limit. So when you have like a 20 amp fuse, it will actually handle 20 amps for a short period of time. But it'll blow like exponentially faster the more you overload it. So a 20 amp fuse will blow very quickly with like 40 amps trying to go through it. And the thing is, this is 320 amp fuses next to each other in parallel. This is effectively a 60 amp fuse. So you would need to overload this by like you would basically need to try to pull like 80 or 100 amps through these in order to get them to blow quickly. That is probably enough current to cause serious damage to the PCB, right? Like probably on the level of what this 3080 Ti experienced. So I am not convinced that this is actually like gonna do anything. Like I think like this is okay, I guess they're trying, but I don't think this is gonna do anything. I could be wrong about that, but like generally you want as small a fuse as possible in front of as like few, well, The thing is, if your fuse is too small relative to how many power stages are connected to it, it's going to blow even under normal operation. So you basically want the fuse to be like just like it needs to be big enough that under normal operation it doesn't blow, and then as soon as like the power stage dies, it blows very quickly. Which I don't think this is going to do, because this is effectively a 60 amp fuse, because there's just too much stuff hooked up to these at the same time. We do still have one fuse on the PCIe slot over here. So yeah, so on Nvidia GPUs, like it's just gotten worse and worse, right? With the 30 series, you could get cards from some board partners where you had a fuse for every power input, and so even if the warranty expired, if you had a power stage failure, it was a relatively easy fix. Now, again, I don't run a repair business, but I would guess you could probably get it fixed for like $50 to $100, because the parts don't really cost anything, and like the parts are like under $5. Right? And then the time spent like troubleshooting it, like if somebody is experienced with repairing GPUs, they should be able to identify and replace a power stage in under an hour, unless it's like burnt a hole in the board, in which case they might not be able to fix it at all. Right? So yeah, like this, like I'm just like, I just find it incredibly disappointing that such expensive cards, like they're just like, it's just getting worse for repairability. And the thing is, on the AMD side of things, we have no such issues, because AMD GPUs don't use stupid power connectors. They use sensible power connectors. They just use more of them. And so this is a 17900 XTX from Sapphire, right? This is also a $1,000 GPU, and we have a 10 amp fuse on the PCIe slot. Right here, we have 120 amp fuse for each of the 8 pins. So this is a perfectly reasonable way of doing things, right? This is like the gold standard. And we had this on Nvidia cards, right? Like the 3090 gigabyte card over here. Mind you, these cards are kind of notorious for having power stages fail, but either way, like at least they have fuses. So it's easy to fix them when the power stages fail, right? This MSI card has fuses. So anyway, so yeah, like Sapphire gets it. They put a bunch of fuses on their cards. And they put fuses even on their cheap cards, because fuses are cheap, right? Or like cheaper cards. The 7700 XT isn't exactly cheap at around $400, but you know, like I don't think somebody would be rushing out to get their 7700 XT repaired in most places. Like it depends. In some countries, it might be cheaper to get it repaired than to replace it. But you know, if you're in like the UK or something, and your 7700 XT dies in 3 years from now, I don't think you're going to go looking for somebody to repair it. But if it did die, and it did suffer just a power stage failure, it would be a relatively easy fix, because there's a fuse on the PCIe slot, there's fuses on the 8 pins. Why can't expensive Nvidia GPUs do that? Well, I mean, other than the stupid 12-volt high power connector, but hey, the 3090 Ti exists, right? And the thing is, the fusing of the way that, like the way it's done on the 3090 Ti, this isn't even necessary. You could have the 12-volt high power connector come in as one big stupid power input, which is what it does on the 40 and 50 series, and then subdivide the 12-volt regions on the board into their own groups, for like, so that you could have like a fuse for every couple power stages, instead of like, well, what Zotac is doing, where they have 3 fuses for the entire card in parallel, which is effectively one giant fuse. So yeah, so that's it for this video. It's just like a thing that I find kind of frustrating, that like we now have extremely expensive GPUs. They become obsolete slower than ever. So it makes more sense to repair them than it used to, like a decade ago. But they're not even, like, in terms of actually being designed for repairability, they're actually getting way worse. And I just find that very disappointing. We'll see if, like, with the RX 9070, if, like, things change. I kind of doubt it. Like, Sapphire, like, I'm assuming Sapphire is just going to put fuses all over it, as long as it's not using a 12-volt high power connector. Like, other board partners don't necessarily. Like, it really depends. Like, it's up to the board partner to decide if they want to put fuses on their card. But at least on the AMD side, the board partners have the choice, whereas on the Nvidia side, it's like, well, you've got the 12-volt high power connector, and you can't subdivide the 12-volt distribution on the card afterwards because Nvidia will tell you no. Or at least I'm assuming Nvidia would tell you no. So you're screwed, right? Like, at best, you can do what Zotac did, and I'm relatively certain this doesn't actually do anything. So yeah, that's it for the video. Hopefully you found it somewhat interesting, if not particularly useful. And if you'd like to support the channel, there are links in the description. It would be much appreciated if you'd check them out. And that's it. So thanks for watching, and goodbye.